Let me show you how we're going to automate the sales drafting process, nearly eliminating our lead time to get our custom boiler drawings into the customer's hands. Here you can see the order form. This is what the customer fills out, and this is the start of the process. It's got all the different features and options for any specified boiler model. It's the same rinse and repeat process all companies have. Customers have to wait weeks on end for the drawings, and while they're waiting, they are looking at other options. So we're going to fix that, and we're going to keep them looking at the same boiler and get sales up. Here you can see I have a custom form that I created with iLogic and Inventor. It mimics all the options and stuff that the order form has. We're going to start off by changing the surface blow down. We're going to get rid of the sample cooler option. Now we're going to change the blow down type. We're going to change it to a manual. Now we're going to eliminate the surface blow down option entirely. And now we're going to change the water column from a probe type to a modulating float type. Now we're going to turn the auxiliary low water cutoff option off. Come down to the reflex. We're going to get rid of that. We're going to go to the standard option. Now let's change the tricox. We're going to get rid of the tricox. We're going to switch it to 3 plugs in their place. Now let's drop down to the bottom blowdown. We're going to change to a knife type bottom blowdown valve. And now let's run the configurator. In this window right here, this is a file explorer window, and this is basically when this code runs, it creates a new folder and it puts all your drawings and everything in a specified location in your C drive. Here you can see the PDFs being made, the IDWs, DWGs, and the step file. And the code is running through. Now let's look in the folder. You can see the gas train PDF, sheet 2 PDF, sheet 1 PDF, sheet 1 DWG, sheet 2 DWG. And now we're going to go to the 3D step model that is cut. So normally without the automation, you have probably about a week wait time for customers. You have 4 or 5 hours of CAD work after a drafter gets the order form, and then they have to send it out and they have to get it approved, and that process usually takes a week. So you can see on the left here, I have different completion times for certain amounts of drawings. For 1 week completion time, however, realistically, you could probably get 10 done since a lot of the drawings, or since a lot of the 3D models are going to be the same. You're not going to be redoing everything. You're going to be changing 1 or 2 components. But still, even at that pace, at 10 drawings a week, it's still going to take you 2.5 months to get 100 drawings done. Now, if we hop over to the right side, same number of configurations, 107,520 different configurations. It's a big number. But for the same amount of drawings, it'll only take you 10 hours, which is one long day, 8-hour work day with 2 hours overtime. And that is a huge difference, and that's going to save a lot of time and a lot of hassle, and it's going to get customers sticking around. They're not going to be switching up companies just because they can't get drawing files. So I just wanted to take some time here, go in and show you a couple things on how the code works. In this order form here, it has, well, I've already talked about it, but it has these drop-down menus, but how it works is these drop-down menus control user parameters, which I defined above, and some of these parameters are Boolean, other ones are just text variables. This 3D model is a master assembly which contains multiple components, both visible and invisible. Components, for example, are these 4 that I'm highlighting. Each component then has its own set of configurations, and the collections of these configurations are called iAssemblies, which are basically Excel-driven tables. I'll show you one here in a second. We'll go to the bottom blowdown. Let's see here. There we go. You go to change component, go to table, and you can see that there's 6 different configurations just for the bottom blowdown. And this is kind of where all of the 107,000 different configurations for the boiler come from, because something like the water column has like 40 different configurations. And I think there's 6 different water columns that are available. In here, you can see in the water column code, there is different cases. So those are your parameter inputs from the form. and then you can see below that there's this component visibility, and you can turn something visible or invisible, and when something is visible, you can then go in and change the iAssembly row to match the order form. Yeah, so that's kind of how all this works. Up here, you can see there's a customer and a project name text box. The code takes the inputs in these boxes, converts them to strings, and then places them in the drawing template. There's a whole other chunk of code which creates the drawing after the model is made. The first thing we're going to start off is deleting the contents, and this is the first step that the code undergoes for every iteration. We'll do that right now. I'll run this code. And I have the main code for this drawing template broken down into chunks so that we can step through it, so that viewers can kind of understand the process and not just seeing the whole code run through. It's nicer to watch each chunk of code run by themselves. We'll start by placing the views, and we're going to place, basically how this works is there are predetermined points that are on both pages where the views snap to, and in the code you can do them based on specific scales, orientations, and view styles. So if you want a hidden line style or something, you can do all that. You just got to write the code for it. Right now we're running the auto dims, and this basically, to make these, you have to place work points in the model and give them a specific name. Then you can call that specific name geometry from the model, and you can convert them to 2D points, and then you can call those points in each view. And there's another bit of code you use to do a linear dimension between the two work points, but that's how that works. The next thing will be the customer connection table. Let's see, we'll just get all these to run. All right, we'll run this code. And the customer connections table actually updates according to the created model and the order form. So if you're making different configurations, they'll have different customer connections tables. The equip spec, that stays the same for all configurations. It's kind of a standard thing for all the models, or for this model. And then the notes, you can see the notes placed on the bottom right. And then there's also this overall footprint, and then there's this unique shaded note down here. You got to refer back to the notes that are on the bottom right-hand corner. Next will be the leader notes, and these also use work points, but you basically start out by, same thing. You place the points, and then you call them in the code, but then you can snap to them for the tail of the leader point, and then you do a two-dimensional line from that, and then that's how you kind of create your leader note. These are definitely the most difficult part of the whole code, because there's so many different places they could snap to, and just to get everything to line up so you don't have everything overlap, and the formatting, that's definitely the most difficult part. But here on sheet 2, we'll run the bill of material code. This imports the bill of material from the model, and it places it in a specific location, and it'll actually renumber it and reorganize it. And now, with everything that we have with this code, we're very happy with what we're able to do. However, our goal is to eventually have the order form and the iLogic form linked together so that drafters do not need to, click through the drop downs. And another goal is to have the newly created drawings just be automatically sent to the customers. That way, a customer service representative doesn't need to do this. And these two together will essentially cut out the middleman, and the process will be much faster. But this concludes the presentation. Thanks for tuning in.